Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about space food. How do people eat in space? So let's dive right into it. Now, we do talk about a lot of rocket engines and this and that, methane and RP1 and all that jazz, but you have to understand, if you want to send people at the end of the day, which is the final goal of space missions, is that we have to figure out how to fuel human, like you and I. How the heck we survive? We survive on fuel known as food. We need food. So food is essential for survival. It's not optional. You can barely stretch it for a few days at maximum. So if you are doing like a starting company or starting country that is like, let's figure out space, yeah, you can get by with like maximum 1 day without food, but after 2 or 3 days it will start to degrade performance. And poor meal, basically, if you have a poor quality food or something that is just not good enough, it will reduce effectiveness, meaning it does not have to basically cause food poisoning or things of that nature to reduce effectiveness. It could just make persons like feel like in a jail, because be mindful, these things are like space stations are not huge. They look huge from outside, but the internal space is not huge. And back in the old days of Gemini and Mercury, they were really like just fancy coffins. So you have to understand that like food will be one of those things that we like on a primordial level. We have to like it. We have to have good food. So if you have poor meal, it will reduce effectiveness, and person would not even know that they are not performing at 100%. They will be performing at 70%. They may not even know it. Why? So, and another aspect is space is a very demanding environment. For example, right now everybody in space is not there for a joyride. All of them are in there is for a work purpose, meaning they have a thing to do, meaning they have tasks they have to finish, and that is very demanding. And God help you if they have to do spacewalk, because spacewalks may look fun in videos, but you have to understand you are inside a football, like, which is pressurized, because outside is 0 psi. You may have as high as 7 to 10 psi. That is a lot of pressure. Basically, you are literally trying to move a football ball from inside. It's going to be painful, and that's why we generally have a saying that astronauts have really good handshake. That's the reason, because they're manipulating the fingers while it's pressurized, meaning it's fundamentally very strainful to do. So it's very demanding, and imagine doing that for 8 hours. That's brutal. So it is demanding environment. It may seem like fun and games, but it is very demanding and exacting, psychologically, physically. So it is something that you have to understand. Proper food, GG. Not proper food, you might as well not send them, because you will be surprised how quickly normal people, normal strong people, even military personnel can become just like useless after that, having improper meal. So snacks was the starting point. Like we had food in the tube and small snacks. That's how we started. But be mindful, this was like only for short duration. This was like a 1961 to 1966 kind of era, Mercury and Gemini missions, and everything was designed in such a way that you can put whole thing in one bite. It's like these are like portioned in small forceps, basically like sugar cube kind of size. It was designed very specifically for that. Now it did work, but they figured out very early on that astronauts were not good with this. They were like, yeah, this is like, surviving, good. 1 day, good. 2 day, 1 week, yeah, no. So the moment they figured out they had to send people to moon, it's gonna be longer than that. This was like, bye bye. That's why this sort of system only survived till 1966. It was just not good enough. You need proper meal for long-term mission. And I do not mean like long-term in Mars. I mean long-term as in even as close to moon, you need good food. And especially when you're talking about ISS, you may need like a full kitchen at that point in time. And 0G makes things very difficult. Now, why I'm saying 0G? Simply because every piece of food follows 1G acceleration when it's on Earth. That's why your things work. That's how you pour ketchup. Everything works based on G's. There is no G there. If you put a G sensor there, it will say 0. And that creates things that are a bit more complex and difficult. Like back in the early days, people were actually worried, can we actually swallow without having gravity as a direction? Thankfully, we could. So we can actually survive in space. So this is a very critical aspect. So what are the problems that we are facing here? Well, first thing you have to understand, energy. Meaning, this is not an issue if you are sending a capsule that is gonna go round and round and come back. That's not an issue. The moment you are talking about anything that is for very long duration, like space shuttle, or something like International Space Station, Chinese Space Station, Russian Space Station, at that point in time, energy becomes a very critical role, because how much electrical energy you have defines how the quality of food you can have, and you have to sanction certain amount of energy for it. You cannot be like all the energy is for communication, research, and no. You have to have certain amount of energy just for luxury. If you can, you have to have it for food. So it is very critical aspect, and that's why refrigerators are not a thing that you will see a lot. Heating and freezing, both of them take insane amount of energy. So it is something that is used very sparingly. You have to be very mindful, very calm about that. And weight is an issue because generally you want to send things that are like just take it and eat. Don't be like take this, do this and do this, because every time you are doing this and this, you are utilizing utensils add weight. So you want everything done in one go, almost like how military does it. So weight is a very serious concern here. You have to be very mindful of the weight. You cannot just like add, okay, one person needs 500 tons of food. Of course, that's how much you would need if you want to like send people for Mars in long duration. But you have to, optimize that puppy in order to send people in 6 months in ISS, so to say. And then again, you have to keep resupplying. So weight is a serious issue. You have to be very mindful of that. And at that scale, weight of everything, including packaging, including spare water and all that just adds up. So food must last as long as possible, even without refrigeration. You may have that as the first line. It's like, bro, this mission is less than 6 months. It must survive 6 months without any intervention, so to say, without any, okay, put it in a heater, then only it can survive, put it in a fridge, only then it can survive. No, it has to be stable for as long as possible. Of course, there are some things that are limited, like not everything is like honey where it does not expire ever, but many things have limitations. So this is one. That's why like you're not gonna have a pizza that is like a ready-made pizza. They're not gonna last a very long time. So, and crumbs are disaster in space. You cannot have crumbly food. Many times you will notice that people are eating a lot of tortillas rather than bread. The reason for that is bread was tried. It had created too many crumbs. Germany is actually spending R&D money on making bread that does not crumb as much or almost zero. But crumbs are not acceptable because, well, how the heck you clean it? You can't. You can't. And crumbs will float. It will go into air vents if you're lucky. It will go to someone's eye if you're unlucky. So it is very, very serious that you do not eat any food that can create a lot of crumbs, flat out. And powder is a no-go, meaning thou shall not bring powder. You can have water, you can deal with water, you can manage water. You cannot deal with powder. Thou shall not have powder. If you carry powder to space stations, they will put dynamite under your ass. Be mindful. Powder is a no-go. No matter what is the importance, what is the... So protein powder, bros? No. No. Just no. And it must be healthy and nutritional because of course these are demanding environment, and this creates a problem because many times things that are tasty are not really that nutritional, but you have to give them both because again they are inside a metal tube. If their taste buds are not getting properly stimulated, they will lose this puppy very soon. So they have to be very tasty, and that's why like pizza or a multi-million-dollar mission, pizza. There was a reason for that. It is one of those things that because of the long span of ISS, we have learned it the hard way that it has to be tasty and nutritional, also be desirable. Basically, it has to be a food where it's like, I can enjoy eating it. Otherwise, your astronauts' effectiveness will go down. From launch, they will like, all the energy is young puppy energy. And after that, it's like, when I am going back? And they won't even know it. They won't be able to quantify, oh, food is garbage, that's why I'm not performing. But like we have enough experience with submarine crews that we know. And that's why like all militaries, like the best chef is always in submarine. So that's the problem. You have to be very mindful of things. So how do we prepare food that is sent up there? Well, salt and pepper is one of those things. But again, those are powder. Powder is no-go. So this is how salt is sent. This is how pepper is sent. Salt is diluted in water. So basically, again, not diluted. So it's like suspended would be correct word. Like it's fully salty water and you just put it in, mix it in your food. And then you have pepper, which is mixed in oil. So that's how salt and pepper. That's why I said no powder. Then main foods, basically things that can be very delicate in sense, they are freeze dried. Now freeze drying is a very important process. If you are interested, please comment below, then I'll make a dedicated video about it. The idea is you kind of freeze that puppy so low the temperature reaches a weird point where we have triple point of water, meaning it could be solid, liquid, gas, all three at the same time. So basically you freeze it and then you let solid ice turn to gas directly without going into liquid phase, meaning the protein structure, basically the structure of food remains intact. Protein does not get damaged, and because you are not utilizing heat there, you are not damaging it, you are not changing any structures, and you are not causing any basically stages of breaking down. Benefit, it retains every single nutritional value. Almost 99.99% of nutritional value survives, meaning it had X amount of nutrition, it goes almost X amount there. So it's a very desirable thing. It is intensive to do, but we figured it out. So freeze drying is the first step. That's how majority of things are done. Then you have thermostabilize, meaning these are generally things that you cook. So inherently they are resilient to being cooked. So you use thermal cooking systems to sterilize the food, because be mindful, these things have to be stable. And freeze drying also basically removes water. So it removes the probability of germs growing uncontrollably. Be mindful, almost all foods have some germs. That's why we have to remove water from them. It's not that like germs is bad for you. Your body is like, it has immune system, it has acid, it got things to handle it. It's just that if it gets overwhelmed, then you are not able to manage it. So freeze drying, it reduces the probability of having any bad reactions, so to say. So freeze drying for delicate things, thermostabilizing for meals, basically ready-made meals, and irradiated food if that like let's say some components like steaks, like basically meat, heavy meats, they kind of need it. There is no other system that would work that effectively, so they're like, okay, gamma rays it is. So irradiated food if it's needed. And almost all things that are sent in space, yes, this is in space, they are self-stable, meaning you can just put it in the shelf and it will work. Now thankfully, because ISS is a completely enclosed system and air conditioned, the temperature is kind of easy. Like self-stable here does not mean that it can stay like well in Indian shelf. Indian shelf could literally expose to be temperature as high as like 35 degrees Celsius or even more than that. So there is some limitation. Thankfully, because of air conditioning, these do work effectively. They can last very long time. And all you can do for cooking is just that, add water and heat for cooking. Not too much more than that. That's the inherent limitation. So that's how foods are prepared. Like you freeze dry them, you thermostabilize them, you irradiate them if you need to, and everything is designed such a way that it becomes as stable as possible for as long as possible. And everything that you have to do in space is just limited to adding water and heating it if it needs to. So how do we package these puppy up? Well, it has to be space safe. What does that mean? Again, it's a safety measure where they are like, what is the outgassing of it? Meaning in zero G things behave a bit differently. So outgassing is done as a test to be damn sure, whereas like over time it slowly starts to evaporate, things start to evaporate from it, gases start to escape it. And that's a very big issue for NASA, where they are like, many of the plastics like that is used in packaging is just not good enough. So they have to create like, their weird packaging is for that reason. Outgassing testing fails majority of them. So it must withstand heat if it's needed. For example, you do not have the, oh, take this package, open the package, put it in a utensil, cook it into a plate. That's not there. Package is the thing that's going to go into a heater. So meaning if you have to heat it up, the package itself should be strong enough. Basically like how we have microwave safe utensils, exactly like that. So it must withstand heat if needed, meaning if you are carrying something in it, let's say coffee, it has to be in a strong enough pouch where it's like, yeah, you can make the whole coffee in that pouch without damaging the pouch. And it must not create mess. That's the whole thing. And that's why you will always notice astronauts are cutting the package, or they'll never cut it completely. So every time they are cutting it, they'll only cut a small slit on it. They will never cut it like, okay, two different pieces, that's a no-go. You must have one piece. So must not create mess. Again, astronauts are trained in a way where they are like, even if they are cutting a box, basically meal box, they cut in an X and only open one slice, eat from that, because all three slices are keeping things down. So it's very mindful. You have to make sure all the packaging supports this no mess policy. And all the packs, basically, they have Velcro. Without it, you cannot manage this. Flat out, you cannot manage a kitchen in zero G. You have to have Velcro for management. And foods are basically, if they are market carried, basically, they will do testing. If they survive the market carrying, you can actually have the whole package there. Many times you will see people eating Skittles and things of that. There are many things whose package have been tested and they're like, yeah, it's good enough. They just send it during launch. But if they like, dude, the package is not good, it may be repackaged. And all of them have a proper barcoding and tracking system, because again, if somebody falls sick, they want to trace it down and figure it out what happened, what was the faulty link, because again, we are human, we make mistakes, so we have to be very mindful of these things. So that's just the packaging department. So what does it mean to cook in space? Well, only few things can be done in space, because you can microwave things, you can heat things, that's it. And microwave is only present in Chinese station at this point in time, simply because while you can put a microwave there, because microwave is a highly electromagnetic radiation active equipment, it does generate a lot of radio interference. So it's not desirable unless you design the spacecraft around it, or be like, okay, this is a specific microwave that is built for this environment where it has almost zero electromagnetic noise interference. Only then you'll put it there. Chinese have done that, and again, ISS is very old, so it's not surprising that it does not have it. But newer Chinese station, I'm reasonably sure any new last station will have microwave, may even have multiple microwaves. It can be done, it's just that hassle. Heating, that's of course the backbone of it, everything. Refrigeration can work in space. It's a thing that is there. There are like, those are refrigerators, tiny refrigerators, but those refrigerators are actually sent for like a mission kind of scenario where they're like, oh, they're carrying a biological material for research and all that jazz, not for food, because it does not actually make that much sense. Think about it this way: why do we have refrigerator in home? We buy fresh fruits, we keep them in the fridge, eat it when we need to. We buy milk, we put it in the fridge, drink it when we need to. So fridge is almost like an intermediate storage. But if your food, all of the food is self-stable anyway, what's the point of fridge? And on top of that, you may be like, from a personal point of view, it does make sense. Yeah, in ISS, fridge would be useful because again, you're going to refill the fridge every few months. You have a mission, you will refill it up. And again, all the private spacecraft, they will have that. Private space station will have that. But like, if you are sending to Mars, fridge, it does not make that much sense because you're going to run out of things to put in them very soon. So unless you are growing food in space, it's not that useful. So refrigerator is always like, that's why even Chinese does not have refrigerator. It's more of a carryover. It's like, yeah, you brought ice from, let's say, ice creams from ground, and you're like, okay, just carry it into refrigerator so I can eat it another day. It works in that sense. ISS, I can see in everything that is in low Earth orbit or even in lunar orbit to have basically fridge. Anything that is going to Mars, fridge may not be as effective. Again, for medicines, awesome, but for other things, not really that useful. So you have to be very mindful, like what you are putting in it and how much of you are putting. Like, you cannot be like, okay, this 30-ton launch, what does it have? A refrigerator which has food in it. Again, it may be necessary, but like not desirable. And it is a must-have step for long duration mission. This is one of the greatest success of ISS, meaning you do not think about it, but again, be mindful. We went from barely having food from tubes to actually cooking pizza in space. It matters a lot. Like, it may not sound like, oh, what's the important here? It's important. It's the important that figured out we can just have a heater briefcase where you can just, like, this was from space shuttle era. Nowadays, they don't need it. They have this sort of heaters to do the work. And they even have fridge from some missions carry over. But you have to understand, it is a necessary thing the moment you want to stay, in space for long duration. For Mars mission, this is compulsory, like having the luxury of having raw ingredients and making them. Of course, things would be limited, things would be restrained. It won't be as free-flowing as like in a submarine, but this is compulsory. And the fact that people can eat this, it's awesome. And it has shown time and time again by ISS research is that better food, better performance, flat out, flat out. So cooking is one of those things that are what we call good things for crew morale boost. Meaning, because be mindful, the joy of space wears off very quickly. And for normal people, it will wear off the moment you have to poop or pee in space. That's the first moment you're like, yeah, space is not as great as I thought. That's the first thing. That will happen, like, first day one, day two. But after a while, it starts to feel disorienting because, like, again, there is no gravity. Your body is designed for that. You cannot sleep properly. So having a cooking as a activity where people are coming together and doing something, it's a very, very important for morale. It's one of those things that we have learned from ISS. It's like, that's why ISS menu went from this, like barely had few options, to this. Like right now you have a lot of option in ISS, and every person, like even if they are from India, they will bring some things that is dedicated to India. If they are from Italy, they will bring things that are dedicated from Italy. If they are from some place of France, they will bring that. China, basically Japan, they will have a lot of things that are like their homeland. They're like things that make them very fond of, like, homeland. It's a compulsory thing. It may sound like luxury, but it is one of those things that for 6 months in a tube where you can't actually do much, you can't even piss and poop properly, and you cannot bath properly, it is one of those things that we need to have. So that's the cooking aspect of it. We have to figure out, and thankfully, if we start to have centrifuge, like how in the movie Martian, we may be able to do even better than this, but right now this is the best we can do. And it's a good thing. That's what we have evolved from ISS. So this was my presentation on space food. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.